The angles of the circle worksheet is the one that we did the first day. We turned it in. We finished it and turned it in. So segments of a circle is what we're looking at now. Angles of a worksheet, or angles of a circle, should already be done, except for the very last page. We did pages 1, 2, 3. And then the very last page is going to be extra credit, and I'll give it back to you, and you can do the extra credit if you want. It would be late today. Like, for the last few minutes. I said it was due before you left. Yeah, that's a good point. Okay. Touche. All right. So, circle conjecture 10, we feel good about. We got our tangent lines. When they hit a point outside the circle, then those two lines are going to be the same length. We're good with that. We've looked at circle conjecture 11, and we practiced that yesterday as well. We saw that if the two chords are the same length, then those arcs are going to be the same length as well. Here's a triangle kind of showing that. Okay, so I think today we are on to circle conjecture 12, which says if you have a radius or a diameter and it bisects a chord, which means cuts the chord in half. Bisect means that you're taking the chord and you're cutting it in half. If it cuts the chord in half, then it's making a 90-degree angle. This one seems to happen a little bit more often. Okay, so circle conjecture 10 and 12, these two. So this first one, I think this first one is pretty easy to recognize, to be honest. You'll be like, oh, there's little lines around a circle and a couple of them are labeled. Let me just label all the other ones. I don't know. I feel like this one's pretty obvious, and I don't feel like we have to typically memorize a lot for this one. Circle conjecture 12 to me feels a little bit weird. I don't know about you guys, but to me it feels a little bit weird. So if you have a chord, you have one of those straight lines in a circle, and you have a radius or a diameter that cuts it in half, then it makes 90-degree angles. And so that's what we're going to look at next on the assignment. And what ends up happening here is you just kind of have to look in your drawings, and you're going to look for radiuses that are drawn. It's pretty common for them to do that, to draw multiple radiuses. I know that the plural of radius is radii, but I feel like that's weird, so I'm going to keep saying radiuses. I'm going to say it wrong because it sounds better. Radiuses instead of radii. Are we okay with that? Yeah. Okay, I think it sounds better. So in these pictures, they'll have a radius drawn in more than one place, and you'll just be like, oh, if the radius is 10 over here, then it's going to be 10 everywhere else in the circle as well. And then they'll also do things where they'll draw that, like the chord, and they'll say like, oh, you're cutting it in half, and so they'll make these right triangles, and you'll end up doing the Pythagorean theorem. That's pretty common for these questions. And so when we look for these problems on the worksheet, we're just going to be aware that it's possible that we might have to do the Pythagorean theorem because they like to throw that in these problems. Okay, so those are the two things we're going to think about as we do these problems. We're going to say, hey, is there another place where they have shown me what the radius is and I should be writing the radius down? And then also I'm going to be aware that at any time they might want me to do the Pythagorean theorem. Okay, those two things I'm going to watch out for. So if we look at number 7, they have an x value in there that they want me to solve for. And number 7 is a very easy problem. Can somebody tell me why it's a very easy problem? You don't even have to do that. You don't. It's a radius, and somewhere else in that same problem you can see what the radius is. 16. So x is labeled as the radius. Somewhere else in the problem, 2 other places in the problem, you can see that the radius is 16. So I don't even have to do any math. I can just tell that x equals 16. Because it's the radius of the problem. X equals 16. Easy peasy. All right, let's go ahead and try the next one. It says that AB is congruent to BC. I'm going to do this in colors because it's kind of hard to label that. So AB, this length right here, is the same as BC. That's the same as this length over here. So those two lengths are the same. DF is 3x minus 7. Let's see. 3x minus 7. And FE is x plus 9. This over here is x plus 9. And that is not the circle conjecture we just did. Is that another circle conjecture? Oh, that's circle conjecture 13, so we're going to skip that one for a second. Oh, number 9 is as well. Okay, so let's look at circle conjecture 13 real quick. So circle conjecture 13 says that if you have two chords in a circle that are congruent, so you have a chord here and a chord here, and you know that they're the same length, then they are equidistant, which means same distance. They are equally distant from the center. So this distance from the center is the same as this distance from the center. So that is what we are seeing in problem 8. So we can see this chord and this chord are the same length, which means that this distance from the center is going to be equivalent to this distance from the center. So if those two distances are the same, what should we do if we want to solve for x? Set them equal to each other. So 3x minus 7 equals x plus 9. All right, you guys good on solving that one? This one kind of does the reverse of that. It says, okay, here's a chord over here, here's a chord over here. The two chords are equally distant from the center, and if they're equally distant from the center, then we know those two chords are going to have to be congruent to each other, because they're both a distance of 8 from the center. So we have chord PQ and chord RS. They say PQ is 3x minus 4, and RS is 14. So if these are congruent, then what should we do to solve for x? Set them equal to each other. All right, when you're done with all of those, go ahead and turn the page. Okay, now I'm going to give you a hint with number 10. I'm going to give you some extra information on number 10, and then I'm going to let you guys see if you can figure out the problem. So what we have is we have that x is right here. This is a chord in the problem. This is a line that goes from the center to the edge. And if the line goes from the center to the edge, what is it called? A radius. So this is a chord, this is a radius. The radius hits the chord and makes a 90-degree angle. What circle conjecture talks about a radius hitting a chord and making a 90-degree angle? Not 13. 12 talks specifically about that, specifically about the 90-degree angle. So what happens in circle conjecture 13, you can see that they showed it's a 90-degree angle because they're just showing that to get a distance, you have to make the shortest length to get from the center to the chord. So you can see that they drew a 90-degree angle there. But the one that specifically mentions the 90-degree angle is circle conjecture 12 because they talk about it being perpendicular. So a radius runs into a chord, and if that happens, if you have that perpendicular angle and a radius bisects or runs into that chord, then what happens to the chord? What do you know about the chord? It is cut in half. So if this side of the chord is 12.6, what is this side of the chord? 12.6. Okay. So we know that these two lengths are both 12.6. We know that this right here, this whole thing is a radius. We know that x does not represent the whole radius. X does not go the whole length. X is only a little portion of the length. Does that make sense? X is not the whole thing, it's only a little portion of it, okay? All right, and then I also know that if I go from here to here, what is that called? A radius. Okay, so I'm going to take this, I'm going to label this as R because that is a radius. I know that this is X, this is what I'm solving for. Okay, and then I'm going to label this little part right here Y because it might be helpful to know what that is. Okay, all you need to find in the problem is you need to figure out what X equals. I want you guys in your groups, don't say it out loud, but in your groups talk about what could you do and how could you find X. Okay? All right, so remember with these problems, things that could be helpful is if there's a radius in one spot, then you know the radius in all the other spots where you see it drawn. And sometimes you end up using the Pythagorean theorem. Okay, those are the two things we talked about as happening in these problems. So go ahead and try that one, see what you come up with. Now, don't tell me the answer, but can somebody tell me what this R is? 13.6, okay. Has anyone figured out what Y is? Okay. So I'm just going to say 5.1 since the other ones are 1 decimal. How did we get to the 5.1? What formula did we use? Pythagorean theorem. So we did y squared plus 12.6 squared equals 13.6 squared. Okay. And then what did we do? Okay. Okay, so this is 158.76. This is 184.96. So y squared is 26.2. And then we got y is 5.1. Okay. And then if we know that y is 5.1, how do we find the x? Subtract y from the radius. So we know that x and y altogether is a radius of the circle. And so we're going to do 13.6 minus the y value. And that's going to give us the x value. And so what is the x value? 8.5. You can, so I only did one decimal place because the problem only had one decimal place, but if you did more than one, that's fine. Yeah. Okay, so you guys know enough information now to be able to do 11 and 12. 12 is very similar to number 10. 11 is very similar to number 9. I think it was number 9 that we did. Okay, so it's important to understand how this is different from the last packet. So in the last packet, we had circle conjecture 8 and 9, and those pictures looked the same. They had an X in them. They had 2 lines and an angle kind of on the outside. So just remember that the last packet was talking about the angles, the measurements of the angles, the measurement of the arc. This packet is different because this packet is talking about the lengths of the segments. So it's talking about how long this segment is, how long this segment is, so it's completely different information. So when you're looking at the problems and you're trying to figure out which set of notes to look at and which conjecture or which formula to use, you're going to go based on, in the quiz review packet, you're going to look at the quiz review packet and you're going to say, am I looking for an angle measurement or am I looking for a segment length? And that's going to tell you which packet of notes you should be looking at to figure out which circle conjecture is going to help you, okay? So these are talking about lengths. So this is different from what we looked at before, okay, even though the pictures look the same. So the first situation is that we have an X in the circle and that the X is split up into 2 lengths on each of those lines. So this is split, this side is split so that you have a length of A and a length of B, and then this one is split so that you have a length of C and a length of D. And then what we know to be true about these lengths is that length A multiplied by length B, so length A multiplied by length B, is exactly the same as length C multiplied by length D. So the product of these 2 lengths is the same as the product of those 2 lengths. There's probably a very complicated proof somewhere online, which I can look up if you're interested.
Pretty much for the next situation, it would be like X and W.
I'll show, this one's completely different, which I'll show you guys in a second. Yeah. So we're going to go down to where the example is for this one, which is actually on the next page. And for this one, the labels are kind of hard to recognize which label goes where, but the 3 goes for this piece right here, and the 7 goes right here, and then the 6.5 and the M. So for 13, you would say 6.5 multiplied by M is equivalent to 3 multiplied by 7. 6.5 multiplied by M is equivalent to 3 multiplied by 7. 3 multiplied by 7 is 21. So 6.5m equals 21. And then how would we solve for m? We would divide by 6.5. And we're definitely going to get a decimal for m. Anyone want to say what they got for that decimal? 3.2? Okay, so 21 divided by 6.5, 3.2. Okay.
The lines in number 12, they're congruent, right?
maybe, but they don't have to be. Yeah, so we're going to do this one next because this formula is kind of weird. Okay, so here is the next formula. The next formula is the entire segment length multiplied by the outside piece equals the second one, the entire length multiplied by the outside piece. So the entire length multiplied by the outside piece for one of the lines equals the entire length multiplied by the outside piece for the second line. I'm going to write down what that is with the letters, but it's easier to memorize the formula or to understand the formula using these words than it is to use these letters to understand the formula. So I'm going to write down the formula with the letters now. So the entire length would be x plus w. That's the entire length. Does that make sense? X plus w. So x plus w is the entire length. The outside piece is the w. So x plus w times w. And then for this one, the entire length is z plus y. And then the outside piece is the y. So when I write it with the letters, it looks really complicated, but it's actually not. It's just the entire length times the outside, the entire length times the outside. Okay? So now let's go ahead and let's try that with some of the problems that are like this. So if we look at number 10, we're going to write down what the entire length is. So with this one, I'm going to do this to show what the entire length is. What is 6 plus 8? 14. So the entire length is 14. Okay, what is 7 plus y? 7 plus y. There's no other way to add those together since they're not like terms. So I'm going to follow the formula. I'm going to say the entire length multiplied by the outside piece, the entire length multiplied by the outside piece. So for this one, it's going to be 14 times 6. 14 times 6 equals the entire thing, which is 7 plus y, times the outside piece, which is 7.
Do we distribute the 7?
And we're going to distribute the 7. So 7 being distributed. So 7 times 7 is 49. 7 times y is 7y. And then 14 times 6? 84. Okay. And then what should we do? Okay. So 84, take away the 49. So 35 equals 7y. Divide by 7, and you get y equals 5. Okay, we're not going to do this one because this is the second picture. So let's look at the back side. Okay, we can do one on the back. Okay, for the one on the back, the whole length is what? 34. Okay, this whole length is x plus 16. Okay, so we're going to do the entire length multiplied by the outside piece equals the entire length multiplied by the outside piece. Okay, and then what should we do? Distribute. So 16x plus Anyone? 256? And what's 34 times 14? Okay. And then what do we do? So 16x equals 220. And x equals, you could do 13.8. Usually in situations like this, if you have a decimal where you can write down the whole decimal without rounding, it's better to do that. So we typically only round decimals where that's a requirement of writing down the decimal, where you couldn't possibly write down the whole thing. Okay. Let's write down the formula for the next one. So the formula for the next one, I actually like to write it down the same way, even though the picture looks different, because you can write it the same way. So I'm still going to say it's going to be the entire length times the outside piece equals the entire length times the outside piece. And I'm just going to know that for this top one, the entire length is the outside piece. They just happen to be the same thing. So for this one, we're going to say the entire length is t, the outside piece is t. And then for this one, we're going to say the entire piece is z plus y, and the outside piece is y.
So T just stops when it hits the circle?
Yep, it's just outside. Yeah, the outside piece and the entire piece are the same thing. Yeah. Okay. So for 11, we've got z, and then for the other one, we've got 16 and 8, which means that the entire length is 24. Okay. So we're going to say the entire length multiplied by the outside piece is the entire length multiplied by the outside piece. So z squared is, we said that's 92? 192. Okay. 192. And then how do we solve for z? Can we just square root it? Okay, so square root 192, 13.856. Okay. All right, so let's grab our packet. Now, 13 and 14 are not bad. Those are pretty straightforward. And then after that, they start to get more variables. So let's try 13 and 14 first, and then let's pick some of the ones that have more variables, and maybe we could do a couple of those together. So, like, let's definitely do 15. That one's going to be kind of funky. Okay, so I'm going to give you guys some time to try 13 and 14, then we're going to do 15 together. All right, let's do number 15. So the formula is not more difficult for number 15. It's just that when you actually go to solve the equation, you realize that the equation ends up being a quadratic, which makes the equation a little bit more difficult to solve. So we're still using the formulas we just came up with when we said it's the entire thing times the outside piece equals the entire thing times the outside piece. So we can already see this one, but for this one, what would the entire length be? Yeah, x plus 5, okay. All right, so for the first one, we're gonna do the entire length, which is x plus 2, times the outside piece, which is also x plus 2. And then for the other side, we're going to do the entire length, which is x plus 5, times the outside, which is x. Okay? And then for this one, we have two sets of parentheses that we're multiplying together, and when we multiply two sets of parentheses, we have to FOIL. So when we FOIL this, what do we get? So x squared plus 2x plus 2x, so that makes 4x, and then plus 4, okay? And then on the right side, what do we get? X squared plus 5x, okay. Okay, so that was the one part that makes that more tricky. As you go to solve the equation actually solves really nicely because there is an x squared on each side, which, so when you're doing this, you go like, oh, it's a quadratic, I should probably get everything to one side, make it equal 0, which is what we typically do with quadratics. We make them equal 0 and we factor it. But if you start trying to get stuff to one side to make it equal 0, your x squareds actually completely cancel, and you end up with just a regular equation. It ends up not being a quadratic any longer. So that works out really nicely. So now we've got 4x plus 4 equals 5x, and then it's easy to solve from there. Number 16, we'll probably do something similar to that. A little bit different, but kind of similar. I'm not going to do number 17, but I just want to make sure that we can find these entire lengths really easily. So if this is 9 and this is 2x plus 1, what's the entire length? 2x plus 10, okay. If this is 8 and this is 2x plus 5, 2x plus 13 would be the entire length. Okay? All right, let's flip to the next page. I also want to do number 21 with you. I want you guys to actually do the problems, so we're not going to skip 16, 17, 18, but we're going to do them. But I just wanted to do a couple more with you guys. Okay, so let's do 21. I think let's do 21. Okay, so the entire length for this one down here would be what? X plus 9. Okay. All right, so let's go ahead and set up the problem. What should I be writing? Go back to this part again. Tell me what I should write for this one. You're really close. So what did you multiply? Okay, so we have the outside, we have the whole length times the outside. Okay, and then what do we have for this side? We have the whole length times the outside. Okay, and then when you FOILed this, tell me one more time what you got.
X squared plus 5x plus 25.
Okay, and so the middle part is really close but not quite. So we would have x squared plus something x plus 25, and we have x times 5 and 5 times x.
Oh, so 10x.
10x, perfect. Okay. So x squared plus 10x plus 25. Okay, and then what would we get over here for this one? X squared plus 11x plus 18. Okay, and just like the last one we did when we did number 15, just like that one, the x squareds are going to go away because we only have one of them on each side. And then what would you guys like to do next? Okay, so subtract the 10x. So 25 equals 1x plus 18. Okay. And 25 minus 18 is 7. Okay. Now this is not our final answer because the original instructions said to find ML. And ML is 7 plus 5, so ML is 12. Okay. All right. We feel comfortable with that stuff? So our goal, we have about 20 minutes of class left. Our goal is going to be to finish this packet. That's going to be our goal.